Oh, you're sharing your teams. Oh.
Okay. My good.
Hi, everybody. Thank you for joining us for our last session of day 1 of Azure Data Week with James Serra on differentiating big data versus data warehouse. If you all are ready, we are ready to begin. James, if you're ready, you can go ahead and get started.
Awesome. Thanks so much, and welcome everybody to the last session of the day. I can imagine if you started the first session, it's been a really long day, so hopefully it'll end on a good note. Again, my name is James Serra. I'm a big data evangelist at Microsoft in the New York City Microsoft Technology Center, or MTC. I spend my days with customers talking a lot about what I'm going to cover today. Big data and data warehousing, what's the difference between the two, what's it look like in the cloud. So that's what we'll cover. I've been doing this for quite a long time. I've been at Microsoft 6 years. I was an MVP for SQL Server at one time and blog extensively at jamesserra.com. A lot of what I talk about today, I go into more detail on my blog, so check it out if you haven't been there before. And I'll try to inject a lot of the experiences I've had over the years prior to coming to Microsoft when I was building solutions and now in technical pre-sales at Microsoft with full day engagements, usually with customers where I just sit in front of them and whiteboard these architect solutions that I'll cover today. I see customers who get very confused with our products and concepts and use cases. And this is what I often see them look like. They try to understand our platform and they feel like they're being body slammed. So I'm going to hopefully prevent that from happening. And at the end of this, you'll come away with some understanding of our products and at least narrow things down to see what may work for your particular use case. At a high level, agenda is going to flow into, we'll talk about data lake analytics. We'll talk about various compute technologies and architecture patterns. I like to talk to customers about the maturity stage when I first engage them. Where are they at in this data maturity stage? Most are in stage 2, where they've started to collect this data in one central location and they're making better business decisions out of it. But it's strictly looking at where they've been, the rear view mirror. Where we try to take them is to help them understand how they can use this data and supplement other data to see where they're going, to get to some predictive analytics, to make predictions on where they're going, where they use AI and machine learning so they can make even better business decisions. And then ideally become to this transformation stage. And this is all part of digital transformation, where you get to stage 4, you're being able to incorporate data no matter what the size or the source or the frequency of it. And to do that, you have to build out a sometimes sophisticated or complex solution. But in the end, you're going to be able to incorporate all this data, so you'll never have to worry to say that you're going to have to say no to an end user who wants a specific type of data, which frequently happens in the on-prem world. And for those customers that come in and they're not quite sure about the benefits of the cloud, I will briefly describe these concepts at a very high level. We look at the cloud will give you the agility. You can scale unlimited. You pay for when you need. You can be more innovative when you're in the cloud, quick time to market. We're talking minutes to build out a database compared to weeks, if not months, when you're on-prem. And then I like to say you can fail fast. I can fire up a bunch of these resources, be various VMs, and I can all shut them down when I realize this solution isn't going to work. Do that on-prem results in a lot of extra equipment and expenses. And then finally, when you get to risk, the cloud is much better than anything on-prem when it comes to availability, reliability, security. Fortunately, nowadays, I rarely have to go over this with customers, especially the security part. They've already been convinced that security is much better in the cloud, and so is the availability and reliability. But sometimes I do have to cover these, and maybe not spend a day with their security team, but once we get through those hurdles, they're very open in the cloud and they're excited to move on. And we're seeing more and more customers too who come in to say, hey, we're getting rid of our data center. We've got a year or two. We're not going to renew the lease. Please help me get to the cloud. And this is where I go into the following slides on how to build out a modern data warehouse in Azure. When we look at the data lake, this is I like to see the center of the world when we get to a modern data warehouse, because I look at big data as all data, and this is what requires a data lake. I can pull in data. Doesn't mean it has to be big, but it could be difference in size and the speed of the data. In addition to the size of the data, is that speed and type. And I want to usually incorporate data that's not just structured by semi-structured or streaming from IoT is a big thing. Internet of Things is quite common now with outputting thousands, if not millions of events per second. I need the way to handle all that. And the bottom line is you want to get the right information to the right people at the right time in the right format. When we look at various approaches over the years, the one that was most common was this top-down approach, where I know the questions to ask. I have to do lots of upfront work to get the data in a place that it can be used, and top-down means you're modeling it first. And that's traditionally been a data warehouse. I have to go in, I have to build the databases and the tables and write the ETL and do a lot of the work just to get the data in the data warehouse so it can be consumed. Bottoms up, think about your modeling later. I don't even know the questions I want to ask, so let me play with the data. Well, I don't want to go through this work just to play with the data. This is where bottoms up comes in, and I can have little to no upfront work to start playing with the data, and then I can model it later. And we'll get into the schema on read and schema on write, and that's a part of this. Is top down is usually schema on write. I mean, I have to do all this work up front, and schema on read is the bottoms up approach. Typically, when you look at top down, is that I know the questions to ask. I'm going to want to find out what happened and why did it happen, falling into descriptive and diagnosis analytics. And then the bottoms up is very good for prescriptive analytics, trying to find out what will happen and how can I make it happen. The data warehouse that we're used to for many years on-prem is that top-down approach. Understand what they're trying to do, the end users, gather all the requirements, and then build all these tools. Using the tools, build all these processes to incorporate all this data. A data lake uses the bottom-up approach, where I can have this data from all these different sources. It could even be Twitter feeds that I want to incorporate, any type of social media, in addition to the sensors and information from devices. But then there's traditional relational databases. It could even be mainframes. I want to land all that data into this data lake without doing any upfront work, and that's what data lake allows you to. And then I can do analysis on that. So schema on reads means I can put some metadata on top of it as I pull it out. And in doing such, I can run batch, interactive, real-time, machine learning, or pull it into a data warehouse. Well, what is a data lake? Exactly what it is. I won't go over all of these, but I keep adding to this list as I think of other reasons why you want to have a data lake. And to touch on some of them, the ability to store unlimited amounts of data. Think of it as I can just hoard this data, and maybe I'll need it later, maybe I won't, but I can find a cheap and expensive way to do that. You can't do that with a regular relational database. It's too costly, too time consuming, and to just collect data unless you really are positive you're going to use it. And the data lake gives you the single source of the truth. It is something that will complement the data warehouse, as I'll explain in a minute. It's not to replace the data warehouse. And a big reason for the data lake also is free up resources for transforming data. In the old world, you have a staging tables in the data warehouse, a relational database like SQL Server. You land the data in there, you have to clean it and transform it. That means you have to kick users off because you don't want to be colliding with them when they're doing reporting. And well, you can't have 24/7 access because you got to kick them off. And then if you run over that maintenance window, you have sorts of issues in there. With a data lake, I can do all the transformation outside of the data warehouse and not collide with end users. So one way to think of the data lake is that you're having those staging tables that used to be in the relational database are now outside of that, and that's part of the data lake. And then lastly, I'll touch on one other thing is to keep the raw data. If I have a presentation, if I have a data in my data warehouse that's in raw format and no staging tables, I may keep a day or two around of that data, but then I delete it all. Well, then if you later on realize, oh, I need to rerun it, there was a bug in my ETL process, I have to go back to the source system and get that raw data. Data lake, you just, because it's so cheap and unlimited, you just keep that data around forever and never have to worry about that again. And then there's a big cost savings that can happen with the data lake when you get into the various layers you can have of, and in Azure you have this high performance layer, this hot, this cold, and this archive layer, all can save money with the trade-off maybe in SLAs and performance, but sometimes that's very appropriate for a customer solution. Within the data lake, once I talk to customers about what it is, and it's really just a glorified file folder, but you have high durability built in, and you have disaster recovery built in Azure. And the challenge then becomes, how do you organize this data layer? Because people had misconceptions about a data lake. They thought they could just put all this data in there and it's this world of unicorns and wizards and it all comes out magically. Well, it doesn't. You need to put data governance in place, probably more so than you would without a data lake. And to that point, you need to think of how you're going to design a data lake. And I spend whole days sometimes with customers just on the data lake architecture. And at a high level, you're going to have some layers. It could be raw, clean, application, sandbox, for examples. And you want to have this organization thought up front so you're not turning this data lake into a data swamp. Within each layer, you're generally going to want to have a folder structure. Here are some ideas of how that folder structure can be. And most times companies have multiple types of folder structures. So within, say, the raw data layer, they may partition it out by subject area, and underneath that, maybe for performance reasons, they separate it out by date. So you have to think all through this. And then you also have dev and test and prod environments that you got to think through how you're going to do all that in Azure. So a lot of thoughts got to be done up front. And I tend to stress with customers about data governance, and it's not just the technology, but the people and process that you got to think through. So in the end, we want to have a combination of the two, a data lake and a data warehouse together, and that's going to get the most value out of your data when you put it together this way. And we'll go through some more of this, but the idea is that the data first lands in a data lake, is cleaned, transformed there, and then some or all of that data will move into a relational database. But you have the best of both worlds, because maybe that power user or the data scientist who wants to access the data in the data lake can do it directly without having to wait for IT to put it into a relational database, where the other end user who really needs the data in a format that's easy to understand, they want to do self-service BI, just drag fields from a Power BI report into a report without having to join or do anything else. That's when the accessing a data lake really shines. And so the difference is, when we look at it at a high level, is think of the data lake as that schema on read, or the data warehouse is schema on write. And most of the time, the data lake can handle any type of data, even media or video files. Anything can be landed in there, where in a data warehouse it's limited to the relational. And so there may have to be some conversion that's done in the data lake to get in the format that can be imported in the data warehouse. You'll find that the data lake is a place where you do a lot of that data discovery, where you want to experiment with data to see if it's got a value. And then if you find it has value, you can make it part of a process to send it into the data warehouse. And I find the data lake is used a lot for streaming, interactive, and machine learning, where the data warehouse is more optimized for that interactive querying approach. But again, they both should be used, and the data warehouse usually will use the data lake as one of its sources, if not its sole source. I find a lot of customers will split it out into these various layers when we look at both the data lake and the data warehouse. Staging and prep is done for the data lake. Data warehouse is your serving, security, and compliance. The reason for that is the data lake is a little more challenging when you're putting security on there. There's no row level security. It's all folder or file based. So because of that complexity of trying to make it into something where it has row level and column level and do all these things that a database or a data warehouse already does, relational database has already, why try to replicate that and instead just move a copy of that data into the data warehouse? because you can do that row level and column level security in there. So some customers will have the data lake only open to a handful of people for security reasons and make the data warehouse for everybody else. And the data lake becomes that area then for the data scientists, power users, when data warehouse is for that serving people. And to touch on other things in there, data lake can also be great at storing older or backup data or archive data. Maybe I delete some data from the data warehouse and move it into the data lake so it can be accessed there. It's still available on there, and performance may suffer, but I'm not having this extra data in a data warehouse that's really, if ever, going to be used. And then I'll find the data lake used a lot of time for one-time reports. Somebody will say, just give me the data. I want to play with it. I want to generate a report. And I'm never going to use it again. Data lake's great for that because there's no work that's going to be done by IT. And as opposed to trying to do it on a data warehouse and doing all this work up front, landing the data for a one-time report, or worse, the end user goes, well, I don't really need that data. I find it's not of value, but you've already spent all this time adding the data to it, and it becomes a big waste. And then think of it as a lot of times the data lake is, I really don't know what the question to ask. I just want to go and query it and play around with the data, maybe get some answers. Where data warehouse is much more specific. I know the questions I ask, I know the reports and the dashboards to build, and I'm going to land the data in a certain model that's going to make it conducive to generating those reports and dashboards. So a data lake is just storage. There's no compute on there. So what kind of compute options are there in Azure for processing that data or querying that data or making reporting off that data or machine learning on that? One of them is Databricks. And this is essentially a solution that's integrated pretty well within Azure that allows you to go fire up notebooks that you can write code. It could be Spark or Scala or R or Python. And I can connect to the data warehouse, or the data lake, and pull in the data in memory in Spark in Databricks, transform it, and write it back out to the data lake. I can even write it out directly to a product like Azure SQL Data Warehouse because connectors are built in for that. And the Databricks clusters, think of it as a giant Hadoop cluster that you can build underneath the covers that can spin up in 5 to 7 minutes. And those clusters can have a auto scaling where I can say, I want a cluster anywhere from 2 to 100 nodes. And they'll go up and down based on the queries that are being sent to it. I can also auto terminate it. So after, say, 60 minutes, I say shut down if nobody's sent a query or some other statement to it. So this means I can fire up a bunch of clusters. Maybe each of these clusters is processing data on a folder within the data lake. Maybe it clusters for long-run queries, short-running queries, data loading. You can set a whole bunch up and not have to worry about a cluster sitting there doing nothing because you can set it to auto terminate. So I see a lot of customers doing that. I think the difficulty with Databricks is you have to sling code. There's no visual interface in there. You're in a notebook, it's got a blinking cursor, and you start coding. And so that could be challenging for some customers. We also have HD Insights. It's been around a long time. It's going to be around for a long time. They're coming out with many new improvements. I have some insight to that working for Microsoft, and I can say that I'm very excited at some of the things that are coming down the pipe. It's also a environment that has clustering underneath it. They do have auto scaling and preview right now, so it's catching up to some of the limitations that Databricks had that it did not. It's behind the scenes Hortonworks. It's their data platform. It's 20 open source products put together that we provide service for, and we make sure all these products work together well. And then every few months we come out with a new version of HDP that has the latest versioning. So you don't have to go on your own and download all these products and make sure they work and not have support. We give you the support for all these too. So that's HD Insights. It just puts a sort of a pretty layer on top of Hortonworks and makes it available in the cloud. So the question I usually get, what's the difference? When should I use HD Insights over Databricks? And I put some of those reasons here. We'll see customers who already have Hortonworks on-prem. or they want to be 100% open source because in HD Insights, the Spark is a little different. And so it's not truly 100% open source. It could be more cost effective if you have to run something 24/7. So HDI may be better because then you're not going to use the auto terminate feature in Databricks. So that could be, because per hour, the HD Insights is cheaper than Databricks. So it may be better for cost purposes. It's also can be used very well with other products like Kafka and Storm and HBase that integrate very well out of the box. Within HD Insights, you fire up a cluster, say I want to have HBase with it, and your cluster will be configured that way. And then there are some regions that don't have Databricks, and there are some number of users constraints with Databricks. And then the popular use case is if you have non-Spark workloads, because Databricks is really focused on using Spark. Not that you couldn't use other things, but it's designed with the Spark user in mind. And if I look at a high level on those products, if I move to the right, it's ease of use with Databricks. It's definitely easier in some aspects than HD Insights. But you can even fire up a VM that's got HTTP or Cloudera on it. I should remove MapR since that's changed. But those could be VMs. I rarely see customers doing that unless they're doing lift and shift right from Hadoop or Hortonworks for Cloudera. And they don't want to migrate yet to HD Insights. But this is the way it looks on the scale. But all these products can use Azure Data Lake storage or blob storage underneath the covers and then just attached to them. So you're separating out storage and compute, which is a big benefit of being in the cloud. What is a fairly new wrinkle in cleaning your data, transforming your data in a data lake is the mapping data flows. Not to be confused with Power BI data flows. Don't get me started how Microsoft confuses people with these names and acronyms, but the data flows, which is now called mapping data flows, is a way within Azure Data Factory to transform the data. So Azure Data Factory, as one of the ETL tools to move data from point A to point B, used to be just an orchestration tool. I always used to say it's ETL without the T, but that's changed. And Data Factory fairly soon will have this GA'd. It's in public preview now. Unless I missed something, it could actually be GA. We change at such a fast pace. Sometimes I even miss this stuff. But it's been in public preview. It's rock solid now. And this puts a visual interface on transforming data, much like SSIS. I think it's even easier to use than SSIS. And it has about 90% of the features that SSIS has, and pretty soon we'll have everything on there. Interestingly enough, when you use Azure Data Factory, it's a PaaS service. There is no compute. What happens underneath the covers is anything I write in data flows, which is JSON, gets converted to Scala and is sent to a Databricks cluster, and the compute is done there. And that Databricks cluster can be scaled, so it can have very fast transformations. And also recently they added a time to live, meaning previously I had to wait until the Databricks cluster gets fired up, which could be 5 to 7 minutes. Now they have it where you can use a cluster that's already warmed up and it takes 1 to 2 minutes. So the time to start the data flow is greatly enhanced. And in the end, you can think of this as a pretty interface over Databricks. So customers who, once I describe how Databricks works, they give me this blank stare and they don't want to deal with Spark or coding. This is a much better option for them. And it's nearly, if not the same as using Databricks straight away. This does a great job at making the performance nearly equal to that. So I'm starting to see a lot of customers use mapping data flows for their transformations. And since it's integrated with data flow, with Data Factory, this could be just one task and moving the data around and executing a bunch of other tasks. Azure SQL Data Warehouse would be the product that you can use to land the data in a relational database. And again, once I land in a data lake, it's not conducive for a lot of end users to make sense of the data there. You want to move it into a relational database. Any large size big data, you want to look at data warehouse, SQL data warehouse. Yeah, you can still use SQL database for smaller size data warehouses. It's very debatable at what that is, 2 terabytes, 50 terabytes. There's options within Azure to support databases up to 100 terabytes databases with hyperscale, but understand that those are mainly focused on OLTP solutions. Even SQL database are for OLTP. So all but the very smallest database sizes, I would recommend SQL Data Warehouse. Even then, if a customer comes to me and says they have 1 terabyte of data, I say, well, where are you going to be in 6 months or a year from now? You're going to want to incorporate data volumes a lot higher than that. So you want to look at a product like SQL Data Warehouse. And that product's going to give you queries that are anywhere from 20 to 100 times faster on there. Because it uses a MPP solution on there, when we talk about multiple parallel processing versus your traditional SMP, what it does is that means it distributes the data over 60 different nodes. It splits the data out. And when you run a query, it breaks that query apart and sends it over to these different nodes and has them execute locally and then sends back just the results, smashes them up, and sends it back to the end user. So this gives you the ability to scale out and have tremendous performance improvement than you would over a traditional SMP solution in there, which is obviously very important when you get into big data and you want queries that are going to take hours on a regular SMP solution. So I recommend this frequently for customers when they're getting into big data. Azure Analysis Services, I sometimes hear people think you don't need this anymore when you have a fast SQL data warehouse, but I very much disagree with that. Azure Analysis Services, this tabular model, I still tend to call it a cube in the cloud, means I can take data in SQL Data Warehouse, aggregate it, and put it into this tabular model. Because you have to look at the end result of what you're trying to do. If I'm having a dashboard, and that dashboard is going against SQL Data Warehouse, many terabytes of data and queries could take maybe 5 seconds, which is you think, oh, that's extremely fast, but not if you're attaching a dashboard to it. And every time you slice and dice, you have to wait 5 seconds to it. That's not going to be acceptable to end users. I can use a tabular model to put aggregated data in there, which is going to take milliseconds response time. With the trade-off is that you're going to process this tabular model at night, so you have to allow for that. But in the end, you can have a very fast solution for end users, as well as provide higher concurrency, because with SQL Data Warehouse, you're limited to 122K concurrent queries, which could be fine for certain cases, even if the queries, because the queues will take just a few seconds to run queries, so you can support a lot of concurrent users. But at some point, if you're talking about hundreds of users or thousands of users, it's going to be too much for a data warehouse, and you're going to want to put that data into analysis services. And keep in mind, you can scale, not auto, but you can scale SQL Data Warehouse up and down through manually or a PowerShell script to satisfy periods of the day, maybe where you have more ad hoc queries and you want to have data loading. But also you can pause SQL Data Warehouse. So maybe at certain times of the day, at night or on weekends, I want to save costs. I'll pause a data warehouse and just have people access the cube, which leads to some more more interesting solutions where SQL Data Warehouse becomes sort of the hub and spoke, and you use the SQL Data Warehouse to load the data. After it's loaded, you can create the cube from it. You can use it, leave it open for a few hours a day for ad hoc queries, but outside of that, it's shut down, and then the data is copied to analysis services or to a data mart and say SQL database, and people access it that way. So I talk to customers a lot of creative solutions in there, because the idea is many times the customer is willing to sacrifice performance for cost savings. Because ideally, I can say use SQL Data Warehouse, put all your data in there, and tune it up to the highest max and just let it go. But that's going to be too costly. So you want to put more creative solutions in there where you can save the customer a lot of money. And other reasons to use Analysis Service Cube or tabular model, I should change that to, is that it creates this semantic layer where the data is already joined. So I don't have to worry about joining a table, say order details, the customer, the product, and so on. All that is done for you. So it makes it very easy for self-service BI. It can handle the many concurrent users with the performance aggregated data. It also supports things like hierarchies and KPIs built in, so I don't have to try to create those things outside in the SQL data warehouse in there. It has advanced time calculations, supports slowly changing dimensions that I talk about. You can use that in combination with a way of cost savings. So I see many customers continue to use analysis services even with SQL data warehouse in there. And I think that trend is going to continue. It gets a little tricky with the fact that Power BI has underneath its hood Azure Analysis Services and aggregation tables and other such things, but it's still using analysis services just within Power BI, and that could be a whole separate discussion, but the idea is still the same. I put this slide up there because sometimes customers want to know what are the equivalent products when we look at open source versus Microsoft products in here. So it took me a while to put this together, but it does come in handy when customers are coming from open source and they want to switch to Microsoft products or vice versa. The benefits of Microsoft products are you get support, and it could be a lot easier to use those products than an open source product is. But at Microsoft, we're very open source, and if you want to use that anywhere along the way in your data warehouse solution, it's perfectly fine. And in fact, most times a customer, when I draw out a modern data warehouse, they already have existing products that they're using. It could be open source or competitive products, and that's fine. We'll just swap out what their Microsoft products with what they're using, and you're going to have just a great solution still. I put this slide in there recently because with SQL Server 2019 going to be released soon, there is the idea of big data clusters on there. And on a high level, think of it as you're building your own data lake on-prem. Inside the storage pool, you'll see we have HDFS where we can store the data. I can access that data via Spark or SQL Server Engine. I can scale it out. And I can also use a newer version of Polybase to query data sources that are in products such as Teradata or MongoDB, Oracle, or SQL Server in there. So it's going to be very interesting how this is put in play, because you can also build out this solution in a hybrid approach where I can have some of these options like the storage pool and compute pool in Azure under Kubernetes, and then have still at the same time access some data that could be sitting in some on-prem data sources. So I'll look for an upcoming blog when this product comes out where I'll talk about how I see this fitting in. Right now, I tend to focus on this is an on-prem solution for customers. And if they want to do something in the cloud, a better way to go maybe with products like Data Lake Store Gen 2 and Azure Data Factory and SQL Data Warehouse, and I'll touch on those. But it's something that's going to be part of the conversation going forward. We also have Azure Data Explorer. A lot of customers don't know about this. This is a great way to get value out of, or insights out of data that's coming in at a very high, fast pace. So if you haven't checked out this product and you're looking at a situation where you're streaming in lots of data, we're talking millions of events per second, or even thousands of events per second, and you want to look at that data and maybe run machine learning on it to see outliers, maybe generate some reports right away without having to go land into a data lake and then into SQL Data Warehouse before you can run queries on it. Data Explorer can handle all this data up front. You won't do any cleaning with it, but maybe that's okay. Maybe I'm looking through security logs and I just want to see certain events pop through that I want to have a quick alert generated for. This is where Data Explorer can come into play. And if we look at a high level, this is what it looks like. It ingests data from all these different sources. We're talking about event hubs, IoT hubs, Kafka. Azure Data Factory could be used to pull its data in from various sensors, even joining that data with maybe a reference table that's sitting in Data Lake, and it lands in Azure Data Explorer. So it has its own copy of the data, very much optimized to be able to have very large, very queries off very large data. And I have demos where I'm querying billions of rows of data, and the response time is 2 or 3 seconds. So it's a great solution for a enterprise or modern data warehouse where you want to do some upfront analysis before it gets to the data lake. I have a good blog that goes in more detail on this product, but it's one of the products that's not very well known. And I find that most of the, I would say all the engagements I have with customers, they don't know very much about a lot of our products. They don't understand the use cases, and they may not even know about half the products. So it's all about educating them on the product so they're using the right tool and they're not trying to use some product that it really wasn't ideal for, just because they didn't know about something else existed. If we look at architecture patterns when I'm in front of a customer, I'm going to ask them a lot of questions. And these are an idea of what I'm going to ask them, because this is going to guide that whiteboarding session on what I recommend product-wise for them to look at. Are they using the cloud now? Is this a new solution or migration? What are their current skills? That's a big one. I don't want to go and recommend some product. For example, if they say, look, we have 30 people here who are super experts in SSIS, I'm probably not going to go and say you should all switch to Azure Data Factory, because you can continue using SSIS as an Azure Data Factory. So you have to be real sensitive to the time it would take to re-educate people as they move to the cloud. So that's a big one. Then you have to look at how much volume of the data it is. Is this an OLTP or an OLAP solution? Are you streaming? What's the end product? Are you using dashboards? Do you want to do some predictive analytics? Do you need to master the data? What's your budget and timeline? It goes on and on. And there's a lot of other questions I can ask. And some of the solutions, architect solutions I'm going to show you, I'm limiting very much so the products that I can display, because it's can be overwhelming. There's so many. But that's the job of my role and many others at Microsoft who are solution architects, is help you narrow down the products, help you understand the use cases. You've got a job to do. You're keeping the engine running. You're putting out fires. You don't have time to go learn all this stuff. So people at Microsoft or partners are the ones that you can go to shortcut the process for you learning. And the technology changes so quickly that it's very difficult to keep up with it. And that's what we spend most of our days doing. When I'm not engaged with a customer, I'm spending time learning about all the new technologies. And this allows me to know about it and then simplify that and let you know just what you need to know based on the questions I get answered to. At a high level, this is what it looks like when I try to categorize the products. I always break it out to you ingest, you got to store, you got to prep the data, and then you got to model it. And focusing in on those categories, I put the products in here that fit each category, being aware that some of these products span more than one area, because Azure Data Factory could also clean the data. And then you have products like Power BI, which can do all of these areas on there. With the difference between the Power BI is more of a self-service ETL tool than an enterprise solution, and this, I'm focusing more on an enterprise solution. That's a whole topic in itself. But this is how it's broken out. And the couple things I'll touch on here is Gen 2. Because in my diagram, I have Gen 2 and blob storage and data lake storage Gen 1. But just to clarify, is that Gen 2 is really the go-forward solution I recommend to all my customers now, because blob storage, which was the first storage available, had some issues with it. One being account and file size limit. It wasn't hierarchical support. So data lake storage came out and took care of those issues, while at the same time having some limitations of things it didn't support, like object level tiering. And for a long time, I had to talk with customers about both products and which one, pros and cons of each. But now at Gen 2, essentially took the best of blob and the best of data lake store and combined them into data lake storage Gen 2. And we're now adding some of the features that were not initially in Gen 2 are now out or in public preview. One being the tiered hot colon archive, and the ability to support blob APIs and HDFS APIs are now in the product, at least in public preview. So within the next few months, you should see No reason to go to blob storage other than maybe to save a few dollars. But outside of that, any new project will be Gen 2. And then for those customers that are in blob storage, there's talk about how to transform that data, which is a whole other conversation. But just focus on Gen 2 if you're building out something new. And it does have hierarchical support in there. So building out that data lake is much easier in a product like Gen 2. Architect pattern-wise, if we look at the products that fit in there, in your basic cloud data warehouse, you're going to look at ingesting the data using Azure Data Factory, storing it in Gen 2, then using Polybase to import that data into data warehouse. Polybase, for those who don't know, is sort of an abstraction layer that's put over SQL Server to allows you to use regular T-SQL over data that's sitting in Gen 2. So I can go to SQL Data Warehouse, I can create an external table. I create a table with external keyword that points to a file in Data Lake for Gen 2. Once I do that, I'm putting metadata on that file, and to the end user, they could not even be aware that that data is sitting in Gen 2. They just know they can query it. Now, Polybase doesn't do push-down query in Gen 2, so it's mainly used for data loading, and this can provide you with very fast data loading where I can parallelize the data that's sitting in Gen 2, sort of split it out and parallelize it on a one-to-one basis with the CPUs that's in SQL Data Warehouse, because we were going to use a lot of those CPUs, and make my loading go anywhere from 20 to 50 times faster than it would with regular SQL Server. That's a serialized approach. And again, you may want to use Analysis Services and Power BI over that. So this is one type of solution. Another is when we get to the modern data warehouses, we're adding products like Databricks or Azure Data Factory that's doing the transformation of the data. So in the previous one, you can say that I'm going to do transformations in a SQL Data Warehouse. However, I don't recommend that. I recommend, in most cases, there's always exceptions that you're going to want to use a Databricks and Data Factory to transform that data outside of the data warehouse, write it back to the data lake, store, and then use Polybase to pull that data into the data warehouse. And when we get into architectures, you may hear talk about a Lambda architecture. And the idea is, in my previous examples, I was focused more on batching data. So I have sources that are maybe SQL Server or some other solution I built on-prem. And during the day, maybe at the end of the day or very few hours, I want to pull that data in. But at the same time, I may have streaming sources. Maybe it's Twitter data that I'm pulling in, Facebook data, IoT sensors. So that becomes streaming layer. But the idea is I don't want to have completely separate products for each of them. I want to at some point use similar products. So that's what the Lambda architecture is I may use a couple products that are different for batch or stream, but in the end, the serving layer is using all the same tools. So we have this hot and cold path that could be satisfied when we look at a real-time analytics solution like this, where the top one is that streaming, where maybe I'm using Kafka and HD Insights to stream that data in. Databricks supports Spark streaming, so I can transform that data, and maybe I want to land it in Cosmos DB for some real-time apps. At the same time, I can use Azure Data Factory, land it in Data Lake Store Gen 2, and then use Polybase to put in a SQL Data Warehouse. Now in this one, Power BI, I should have an arrow pointing up. I can have that go against Cosmos DB. And I'm also both using Azure Data Lake Store Gen 2 because I can have that streaming data not only have part of that go through in Cosmos DB, but maybe other parts of it can land in Gen 2. So I'm using some of the same technologies for both the streaming and the batch. So wrapping it up, and I'll leave it like 10 or 15 minutes for questions, is think of the use cases where I can use a modern data warehouse. And with customers, I try to put them in different industry buckets. So it could be customer analytics, where I need to see a 360-degree view of the customers, but I also want to do some predictive analytics, maybe to help me with customer churn. So maybe I'm making them some offer if I feel like they're going to leave based on this machine learning algorithm that's coming back with a probability. Maybe I want to use it for fraud or delinquency handling, which gets into, in particular, the financial modeling with banks and stuff, where they do the fraud checking. Maybe I want to do simulations. I'm seeing a lot of customers in the New York metro area now are doing portfolio simulations using machine learning modeling. So that's a great area to focus on. That's nearly impossible to do on-prem. And so a lot of these financial companies are expanding into the cloud just so it gives them the processing power and the space to handle these large amounts of data that they just couldn't do on-prem. Again, the risk and fraud threat detection is popular among banks and retail markets. They also want to see trends and use machine learning to, say, predict who would most likely buy this new product that they come out with. And so instead of trying to sell to everybody, they sell to a specific group and ideally have the same success rate as they would if they tried to blanket everybody. And then we get into credit analytics, is another big area for modern data warehouse, where we look at taking data from CRMs and risk and credit and coming up with who should we offer credit cards to? Who should we approve loans for? What are some of the compliance that we got to check for when we pull this data? And the cloud allows you to do all that. And finally, market analytics. Let's take data from products and services and customer service data and come up with recommendation engines. So when I buy a product, it'll come back on the fly and recommend another product you may be interested in there. And maybe get customer sentiment analysis. A popular one is with customers pulling in Twitter data and finding out if these are good or bad tweets or neutral, but then pay attention to why in one region of the country we have all this negative Twitter activity going on, and then dig into there and find out what's going on and then respond to it. Stuff that's, again, nearly impossible to do on-prem, you can now do with the cloud. So it opens up the ability to get better insights to your data, make better business decisions, and do some more predictive analytics to jump ahead of your competition and satisfy your customers, as well as upsell and cross-sell, and in the end, make more money. And one thing to mention, we do have this architect design guide, which goes over some of these various technologies that I talked about, some of the concepts. So you may want to check that out on the link on the upper left. And then there's my blog, which I'll just pull up here. I created this fact page. So if you go to jamesserra.com, some of the questions you may have could already be answered in my presentation or in one of my blog posts. So I put them all out there to make it easier. These are the most common questions I hear from customers as I deal with them on a weekly basis. And so I put this section together to make it easy to follow up and see what I wrote about it. So with that, I will turn it over for questions.
Great. Are there published best practices on how to best organize the build out of a data lake? If not organized properly, it will quickly become a mess.
Yeah, this is an area where there's not a lot out here. I put in here, how should I organize my data? And Melissa Coates did a great job at some of the blogs about this. I do have a deck, which I'd happy to share with somebody if they want to shoot me an email to jamesserra.com on that deck on architecting out a data lake. There's surprisingly not a lot of information out there. And one of the things I'm doing is to try to come up with a workshop that goes into more detail on that with customers. And I've done it a couple of times, and these are 1 or 2 day engagements with customers. So that's the long answer. The short answer is there's a few links here, but not much else out there because this is so new. And I look forward to publishing material in a short time. And maybe Pragmatic Works has some of that, so you may want to reach out to them. See, I gave you a good plug.
Thanks. That I will have to pass on to someone and find out.
Yeah.
All right, next question. If data is coming from application relational tables, is it still a good practice to extract from these tables to some type of file-based format and store in the data lake, which would eventually feed the DW relational tables?
Yeah, and this is great because the first two I've already answered on here, and they're common questions. And I'll just summarize what I have on that because I put it on here. If I have a data warehouse, do I need a data lake? And the answer is it depends on the data source, in that ideally you want to have everything go into a data lake, but there may be certain data sources that can bypass the data lake. And I always bring this up when I go into a engagement with customers, is that maybe there's a case where I have SSIS packages written and they're writing from a source system to a destination data warehouse in there. I'm not going to go to a customer who may have had thousands of these packages and tell them to rewrite everyone to go to a data lake. Yeah, they'll lose out on some of the benefits of the data lake, or really all of them, but it may not be needed in a data lake. Maybe the people accessing the data lake are not going to need that data, and so you don't need to match it with other data. And because there is an extra step, you have, if it's in SQL Server, say on-prem, you have to extract that out into a, say, CSV file and then put it on the data lake. Well, if nobody's ever going to use it in the data lake, maybe I don't need that. But I tend to find people think they're not going to need it in data lake, and they wind up doing so. Then they write it directly to a data warehouse, and then they wind up pushing it back out to the data lake. So what most customers do is to get into the cloud quickly, is they may only have some of the data go into the data lake, and then any new sources go into the data lake, and then over time they rewrite their packages to all go through the data lake to get all those benefits, like having data in there in a raw format permanently, having access for the data scientists and such. But in every case, I do see times, almost every case, I do see times where some of the data is bypassing the data lake.
Okay. DAX has a long learning curve, so why not rely on the database?
Well, say that first part again.
DAX has a long learning curve.
Oh, DAX. Okay. So for those that don't know, DAX is part of Azure Analysis Services as a language on that. MDX is the multidimensional type of language. DAX is the tabular model, and it does have a longer learning curve. So customers who are not wanting to get a DAX have some options. One of them is Power Query, and that allows you to clean the data very easily. And it's sort of using DAX behind the scenes in a way, but it's all visual interface. And one thing I didn't mention on is in Azure Data Factory, they now have wrangling data flows, which is another way of pulling in data and cleaning it using Power Query. So think of it as Power Query in the cloud. Same thing as, I'm going to confuse people, Power BI has data flows, and that's also using Power Query. So think of wrangling data flows in Azure Data Factory being similar to the Power BI data flows by both using Power Query. So that combined with the mapping data flows, it gives you a visual interface to avoid having to use things like DAX. And I won't say that there's no code, but mainly when you're using data flows in Azure Data Factory, it's filling in properties and not really coding. So it's very easy. But you have the freedom, if anything gets more sophisticated, you could go to DAX, or you can go to Azure Functions and write something out to extend what is limited in the product you may be using.
Could you provide a script or command for pausing the Azure Data Warehouse based on usage?
Pausing the data warehouse is...
Yes.
Yeah. Data warehouse has the ability to pause, but there's no auto pausing, at least not yet, where you can say shut off if nobody's using it. So what I'll see customers doing outside of just manually pausing is they'll write PowerShell scripts that run at certain times of the day to shut it down. Or sometimes they don't ever want to shut it down completely, so they'll just lower the service tier, the DTUs, to the minimum. So it's still open, but they're not having to pay as much because they've scaled it down.
All right. So this question has been asked a couple times. Basically, any news on Azure Analysis Services supporting multidimensional models?
If I had $1 each time.
Well, you'd have 2 from this session.
Yeah, I'd be $2 richer. So there's only certain. This is where I go to the program managers when a customer asks me that, and I said, let them be the bearer of the good news, because this has been asked for many times over the past year or so. And from my knowledge is it's on the roadmap, which means I have no idea when it's going to come out, but they do see it as a high priority. However, I have no inside knowledge of if and when they're working on it, but they do hear customers loud and clear that they need to support multidimensional. And every time I reach out to them, they say it's on the roadmap, but I never see it come out. So send me a question or that question to, again, jamesserra3@gmail, and I can give you some answers under NDA.
For building modern data warehouse, which type of team members / skills will be needed on the team?
Yeah, this goes to the people and process. And it's another topic that doesn't have a lot of information out there. And it's part of what I'm writing up when I talk about, as I mentioned before, the best practices for a data lake is also the people and processes that are needed for it. And I don't have anything written as far as a blog for that. Honestly, this is where I rely a lot on partners, because they are the ones that are building these solutions and have the most expertise at understanding the people and process to put in place. So at Microsoft, we rely heavily on partners, and this is when I pull them in, like a Pragmatic Works, who can have a better discussion about that than I could.
Thanks. What are Azure functions and how can we use it here?
Sure. Azure functions are a serverless product that allows you to go, essentially you go to a portal, you open up a panel, you start writing code, you save it, and then whenever you need it, you call it. There's no installing it somewhere. There's no idea of a VM or limits to how often it can be called. Truly serverless. So I'll see functions used everywhere in our products. It could be Azure Data Factory or Microsoft Flows, or Logic apps, Power apps. The idea being, if I ran some limit into the product and I need to do something special that it doesn't support, I can call Azure functions. So it's a lot of times created for, maybe I'm doing some calculation that I just can't do, or I need to call some other library that I can't call directly. I will write an Azure function for it and just call that from a product. And because it's serverless, it's very easy to do.
Okay. I heard a rumor that Cloudera is coming to Azure, similar to Databricks. Your interpretation of that?
Can you tell me the name of the person who said this? Because I want to have a chat with them.
His name is Chris.
Okay, I have to be careful because I can't say certain things. As I mentioned, underneath the covers of HD Insights is Hortonworks. And it'll be like that. It'll be supported for like that for a while. And maybe down the road, something else happens within HD Insights. But for now, we use Hortonworks. But we hear customers who are concerned because Hortonworks Cloudera have merged and they're coming out with another data platform. So really all I can say is that we are aware of that, and there are solutions that we think people will be happy with. And if you want more details, send me an email, and under NDA, we can tell you more things. And in the end, I'm getting at is a lot of stuff can't be publicly talked about, but at Microsoft, we're happy under NDA to talk to customers about a lot of what's in the roadmap. And frequently when I have customers in here who are under NDA, I'm talking about products that are in private preview or even months from being in private preview, because I want them to know about it so they can plan accordingly. And I don't want a customer coming back a few months later and saying, why did you tell about this product? It's been announced and now it's going to change all our plans in there. So I spend a lot of time being educated on these products that are a while from being out, and therefore I love to share those, but it has to be under a NDA format.
Got it. Well, it looks like we are out of time. I think there are a couple questions that we didn't get to, but I think they might be on James's blog. So I highly encourage you to go there. I know he will be probably he probably already has these slides available on his blog, but we will also get them for you. And when we email all the session materials out, we will get that out to you. James, thanks for a really great session to end the day. We really appreciate it. Thanks for all the questions, everybody. We appreciate the interaction. And we will see you guys bright and early tomorrow morning. Thanks
everyone for attending.